Hello everyone, good evening, and this is going to be our lecture number 3 on multivariable calculus. And multivariable calculus is one of the very important topic that is being covered at ECS Academy at this moment. So we have already covered single variable calculus. I think many of you might have enjoyed. So in engineering, if I talk about electrical engineering, electronics engineering, or you can say machine learning or aerospace engineering, mechanical engineering, civil engineering, any sort of engineering, right? So this multivariable plays an important role. In fact, people who are preparing for GATE data science and AI, they must also go through this multivariable calculus. Okay, that will be very useful to understand machine learning algorithm, right? So in this session, I'm just going to give you a brief because these are the foundational lectures. I have only I have conducted only 2 sessions till now on multivariable calculus. So we have been talking about vectors only, right? So this lecture will also be around the equation of planes, right? And we will talk about some important concepts, okay? And these kind of concepts will directly hit in your brain, okay? And they will help you solve problems very quickly, okay? So let's move to our favorite board, right? So this is our favorite board, you can see. And this is going to be our lecture number 3, you can say. And we are going to talk about equation of plane, guys. Equation of plane. So already we have seen in previous lectures, okay, how does our equation of plane look like, okay? So you should know that the general equation of plane, right, and that is nothing but, so we have to recall, okay, so what will be the equation of plane? What will be the form of equation of plane? The form of equation of plane is going to be what? An equation of the form, you can say, an equation of the form, equation of the form ax plus by plus c, z equal to d. So this is nothing but the equation of a plane, you can say, right? So an equation of the plane, you can say equation of a form ax plus by plus cz equal to d. Okay, that is going to be called as what? That is going to be called as you can say the equation of a plane. Okay, so that defines a plane, you can say. That defines, this defines a plane. Okay, and what is plane, guys? Plane is nothing but a flat seat like structure. Okay, plane is nothing but what? Flat seat like structure. Seat like structure. Okay, that is very important to remember. Plane will be always flat. Okay, plane will be always flat, and it has to be seat like structure. Okay, so an equation of the form ax plus bx by plus cz equal to d. Okay, that is gonna be the plane. Okay, equation of a plane, and these a and b c, all these are the numbers, you can say, right? Okay, where a b c d are just numbers, right? You can say these, the coefficient of x and the coefficient of y, coefficient of c and d are the numbers. Okay, so you must know that. Okay, तो अगर कोई आपसे पूछता है, if you see this kind of equation in your life, in fact in matrices, whenever you talk about linear algebra, right, so you might have seen this kind of equation, right? Okay, and in fact set of equations, so we call it system of linear equations. Okay, so they represent basically a plane. If you take a single equation and there are 3 variables x, y, g, and that is equal to something, some number d, you can say, that equation basically represent a plane. Okay, please remember these points. Okay, in linear algebra, if you want to understand things geometrically, okay, if you want to visualize things geometrically, so you need to have the knowledge about the multivariable calculus as well, right? So because as the number of variable increases, so figuring out the geometrical understanding, or you can say kind of visualizing the you know concept, okay, more than 3 variable becomes very difficult. Okay, so I'm just going to talk about it. See, we are studying multivariable, but what do you think? Multivariable means n dimensional, n number of variables? Yes, but we will be restricting ourselves up to 2 or 3 variables only, not random. 2 or 3 variables, okay, so that we can realize it manually. So an equation of the form ax plus by plus cz equal to d, this defines a plane. Always remember this point, okay? I hope this makes sense, right? So let's see how this is going to be, how this works, okay? So let me take one example here, okay? So let's take one example. So the equation of a plane through origin, if I say that the very first example is nothing but, you can say that the plane through origin, what? Plane through origin. Plane through origin, okay? Plane through origin with normal vector, normal vector, you can say. So how do we represent normal vector? Normal vector is nothing but an vector, you can say. Normal vector is written like this. N vector is nothing but, I'm just going to mention the component, guys, okay? I'm not focusing on the direction and all. I'm just going to put the component, okay? Component of the vector, and we are going to use this kind of a bracket, okay? I think you know this, okay? Greater or smaller symbols, okay? So you can say 1, 5, okay? 1, 5 and 10. So this is going to be our normal vector, okay? So we have to find the plane through origin through normal with a normal vector. So what is given in this question is, in this example, is a normal vector is given and you have to find a plane, okay? And that plane should pass through origin. That is a question. What is the question, guys? The question is, you have to find the equation of a plane, I mean to say, or a plane, you can say. That plane should pass through origin, okay? And only one thing is given, that is normal vector is given. If you are given a normal vector, so how can you find a plane, equation of a plane? Can you think about it? मान लो आपको इंटरव्यू में पूछा गया, see, this concept will be the part of any complex question or a big question, you can say, okay? And these concepts are very much needed to understand linear algebra geometrically, okay? Because nowadays, linear algebra is studied with the help of, vector space, or, you must have a knowledge about vector space. You must have a knowledge about basic geometry, right? How plane look like, how, line look like, okay? How one dimensional line, how two-dimensional plane, all those things, okay? So if you want to find the plane, okay, plane through origin with normal vector, okay? So how do we, since we have got a normal vector here, 1, 5, 10, so my question will be, how do we find an equation of the plane? What is question here? How do we find an equation of the plane? An equation of the plane. Please understand everything step by step, okay? Don't move very fast, okay? आपको ये सारी चीजें पता होने चाहिए. If you do not understand these things, then the tough concept you cannot understand, okay? So आपको, you always ignore basic things, right? If somebody is asking, if you have been given a vector which is a normal vector, okay? Normal vector means what? A normal vector is a vector which will be perpendicular to the plane, right? Let's say this is a plane here, right? So this is going to be a normal vector, you can say. It will be perpendicular. Normal means perpendicular, okay? So we have been given a normal vector only, but what they want is, they want to know the equation of a plane, okay? So how do we find out that equation of a plane, okay? So we can get an equation by thinking geometrically. So let's say, let's think, geometrically, okay? I'm just going to think geometrically, okay? To get the equation of a plane, what we can say here is that, let's say that this is a three-dimensional picture, x, and this is y, and this is g, right? So there are three variables. So we have taken three-dimensional picture, okay? So what are thinking going to be here? So we have x, y, and g axis, okay? And we have the normal vector, right? We have the normal vector n. Let's suppose there is a normal vector n, right? So you can say that this is a normal vector n, okay? And this normal vector has a component 1, 5, 10, right? This is a normal vector n, okay? I'm not showing you the point here, guys. Okay, point will be represented with the help of small parentheses. Okay, but here I'm using some bracket. Okay, kind of thing. Okay, so remember that we are just representing the component of a vector. 1, 5, 10s are the component of the vector, right? So it is, this normal vector is supposed to be perpendicular to our plane. Okay, and our plane passes through origin here. That is very important to remember. Okay, so this is supposed to be perpendicular to the plane, you can say, right? Perpendicular to the plane, and the plane passes through origin. So plane passes through origin means what? You can say that this plane is passing through origin, right? This plane is passing through origin. Okay, if you recall, system of linear equation in case of matrices in linear algebra. So if plane passing through origin means what? That is nothing but homogeneous situation, right? Homogeneous. Okay, understand? So remember that this null vector is given, and my question was, how do we find out the equation of a plane, right? So from the null vector, how can we find out? So here what we have to make sure that this normal vector is perpendicular to the plane. Okay, that's why we call it normal as well. And this plane is passing through origin. You will find the situation as well where plane will not pass through origin. Okay, that is also the very important point. Okay. So when, see, so what they are saying is, we want to think of a plane that's perpendicular to this vector. Okay, that normal vector. Okay. So let's say one point is there. Let me take one point on a plane, right? So since we are saying that this vector is perpendicular to this, you can say plane. So let me take one point here, P. Okay, I'm just going to take one point P here on the plane itself. Let me choose some different color, right? So let's say this is a point P, right? Okay, and if this vector is perpendicular to this plane, it means this is going to be also perpendicular to this vector. Okay, P. Okay, this vector P, right? So I mean this point P, you can say. So this is origin here, and this is kind of a OP vector, you can say, if you join a line with this point P. Okay, if you take a point P which has got the coordinate as x, y, g, right? So as long as this normal vector is concerned, okay, this normal vector is perpendicular to this plane. Okay, so if you take a point P on this plane, okay, so this OP is going to be perpendicular to this N. Okay, so P is in the plane. Okay, when we can say that this point is going to be in the plane. What is the condition? The condition for P to be in the plane is what? The condition for P to be in the plane is what? Can you tell me? क्या कंडीशन है कि ये P जो है इस प्लेन में है? So P is in the plane whenever this OP, you can say, this OP means this distance, and this normal vector, okay, dot product. Okay, so remember that P is in the plane. P is in the plane. Okay, P is in the plane whenever the dot product of OP dot N is gonna be 0. It's a very important point. I think many of us do not realize it. ठीक है, ये कुछ important points हैं जो आपको पता होना चाहिए. Okay, let's say that only normal vector is given. Only normal vector is given, and you have to find the equation of a plane. I will tell you the shortcut as well. How can you quickly write if normal vector is given? कैसे आप डायरेक्टली how can you directly write the the equation of a plane? मैं आपको अभी बताने वाला हूँ, है ना? And that concept only you have to use in the exam so that you can get quick equation of a plane, right? So normal vector is given, okay, and we consider that plane is going to be perpendicular to this normal vector, and we are now choosing one point on a plane. And we claim that this point P is going to be in the plane only when the dot product of this OP vector and the non-vector is going to be 0. Okay. So we write that explicitly that vector OP has a component x by g, right? So you can write here. So P is in the plane. का मतलब क्या है? Implies that P is in the plane implies that what? OP dot n vector is gonna be 0. So you can explicitly write here. OP is nothing but a distance from the origin, right? That point and the distance. So you can find out that that will be x minus 0 by and g. These are the component and dot product C. If you want to find the dot product, okay, you need just component. Okay, so you don't have to worry about directions. Just focus on component. N is 1, 5, 10, right? So if you're going to take the dot product, how to take the dot product? You have to just go for component wise multiplication, right? So x into 1. So it is x plus 5 by plus 10g equal to 0. And this is nothing but equation of a plane. Equation of a plane. So this is how we find out the equation of a plane. If we have been given a normal vector, ठीक है, देखो हम लोगों को क्या होता है ना, in most of the coaching you might have seen, in fact I have also attended coachings when I was preparing for GATE. So मुझे भी ऐसा ही बताया जाता है, मतलब जस्ट कि हाँ ये क्वेश्चन है गेट एग्जामिनेशन में आया है, ये फॉर्मूला है, बस आप याद कर लो. अब देखो क्या होता है कि there are diverse kind of student, right? The student come from different place of India, right? So we don't know that which student is gonna be good in the basics or foundations. Okay, so what I always realized, you know, when I started teaching for GATE examination is I thought of teaching everything from the basic. Okay, so you should know what is this normal vector, what is this equation of a plane, and how can we ensure that a point P will be in the plane, right? So what is that condition? So condition you have to remember, right? This is a condition, and once you are applying this condition, you will be able to get the equation of a plane. So you are explicitly writing, okay, the OP vector, and since OP vector has got the component, you know, you can say x by g. Okay, OP vector has got the component, or you can say this is just a point, right? This is a point, you see, x by g is a point. But if you try to find the OP vector like this, okay, then find the OP vector. This is nothing but OP. Position vector we call it sometimes. So you will get x by g. Now it is a component because x minus 0. You know how to find the distance between 2 points, okay? So can you notice here something here? You know, we have got, you know, so n has component 1, 5, 10. And that gives us the equation of our plane. Okay, so can we think about this a slightly different problem? Okay, so let me take one slightly different problem. Okay, so second question is going to be this. I mean, I will conclude, don't worry, but one problem I told you, right? Normal vector was given and we have to find the plane through origin. Finding plane through origin means finding an equation of a plane through origin, right? But now let us take a different problem, right? So plane through a point. Now they are not saying origin, plane through a point. You can say P naught. See, they are not saying that plane through a origin. Okay, now they are saying plane through. Okay, understood. So we are now trying to find the equation of plane through a point. Okay, so P naught is nothing but 2, 1, minus 1. This is a point. Okay, I have already introduced the notation in my classroom, right? And perpendicular normal is going to be what? And the normal vector is going to be, and normal vector is going to be what? It has the component, you can say same, 1, 5, 10 only, right? Let me take 1, 5, 10. Okay, 1, 5, 10 only. So plane through a point. This time we are not considering a plane through origin. Yaad rakhna. I'm trying to find the equation of plane through a point. Okay, this point is going to be the plane is going to pass through this point. Okay, remember that. So plane through a point, and the normal vector is going to be this. So we are going to use same method, guys. Okay, we can again think this equation of plane. Okay, to find equation of plane, we can use the geometrical understanding only. So let me solve this. So answer is going to be what? Let me draw. This is x, this is y, and this is g. Okay, and we say that this normal vector is there n. Okay, this n is going to be 1, 5, 10. So this is normal vector, right? No problem. Okay, it is perpendicular to a plane. Okay, so our normal, and it is going to be perpendicular to you can say both planes, right? Whether the plane passes through origin or whether plane does not pass through origin, right? It should be perpendicular. That's what we have to make sure, right? So uh, what we can do here is we had a plane, right? We had a plane passing through origin. Okay, you might have seen in the last in the last problem, there was a plane like this, and that was passing through origin. Yeah. So this is the origin, right? There was a plane which was passing through origin. Okay. Understand? I hope this makes sense. So our two plane, see now what they're saying is a plane is not passing through origin, it is passing through a point. So both plane, a plane passing through origin and a plane which is not passing through origin, both plane will be parallel to each other. Okay. Only difference is going to be, we had a plane of this kind, right? We had a plane of this kind, okay, which is passing through origin, okay, and that is perpendicular to the normal vector n and passing through origin. And we have new plane that is not going to pass through origin. Only there is a difference of the plane which is not passing through origin, okay, but it is going to be perpendicular to a normal vector. Okay. So let's say that point P naught is here. Somewhere here it is. Let's say here it is a point P naught, right? So this plane is going to be passing, not passing through origin. Just I'm drawing, okay? Just what we are doing is we are just shifting, okay? Parallel, okay? This point P naught, which is you can say 2, 1 and -1, right? So this point, this plane is now passing through origin, and we have to find the equation of a plane of this. Okay, we don't have to find the equation of this plane. Okay, but both planes are like more or less same, but there is a difference. The key difference is the plane is not going to pass through origin, but it is perpendicular to the normal vector. Okay, so there is a shift. Okay, you can say you are just shifting your plane. So how, so my plane is now what? Instead of passing through origin, right, it passes through a new point. Okay, and that new point is going to be P naught. So how I'm going to do that? So for a point P to be in our new plane, let me say that one point, new point you can take. Same story. Let's say this is a point P, x by g, to be in the new plane. For point P to be in the new plane, and this new plane is nothing but what? Which is passing through a point P naught. That P naught is nothing but what? Through which the plane is passing through, right? So a point P to be in the plane, what is the condition, guys? The same condition we can recall. Okay, what we can do here is since this normal vector is gonna be perpendicular only, right? This normal vector is gonna be perpendicular, so we have to just find the vector here, right? I mean, if we can find the distance, okay, right? P naught, okay, P naught vector we can find, okay, but this vector is not originated from the origin. It is starting from the point where the plane is passing through, right? So what is P naught vector? we can only write the component, right? So component will be x minus 2 comma y minus 1 and g plus 1. I think this is clear, right? This time, my plane is not passing through origin. My plane is passing through a point, right? P naught, that is 2, 1, minus 1. Okay. That is 2, 1, minus 1. I think this is clear for all, right? So please do remember these points. So this is P naught. And now if this point P in the new plane, what is the condition? P naught vector. We have to take the dot product with the normal vector, and that should be equal to 0, right? Yes. So we have to make sure that this P naught P is perpendicular to n. So P is going to be in the new plane, right? So we can say that P is in the plane. P is in the plane means PP naught dot null vector is going to be 0, right? But now this is not a OP kind of thing, right? It is different. So we can write this as x minus 1. Let me recall that. X minus x minus 2. Okay. X minus 2, y minus 1 and g plus 1, right? And dot product with the norm vector 1, 5, 10. Now what we can do here is it is x minus 2 plus 5 by minus 5 plus 10 plus 10g plus 10 equal to 0. What we have to do here is we have to just go for component wise multiplication. ठीक है, इससे easy explanation आपको कहीं नहीं मिलने वाला है. हर जगह people will make you fool in gate segments. Okay, people those who teaches mathematics. Okay, so whenever the concept comes which is a school based concept, or you have to really focus on that, they will tell you the conventional way, and conventional way is also, but that is difficult to understand. Okay, so a point to be in a plane in linear algebra, these concepts are going to be very useful. Okay, remember that. Okay, if a point is there in the plane, how can you ensure that? So there should be a normal vector, okay, and you have to take the dot product, okay, and that dot product should be equal to 0, okay, and that is going to give you the equation of plane. So can you solve this further? So this is going to be equal to x plus 5 by, I think you can notice here, that is plus 10g equal to, this is 7, and then you will get so this is minus 3. So this is the equation of a plane now. Equation of a plane, but this time there is a right hand side also. There is a right hand side. Okay, why there is a right hand side? Why there is a minus 3? Earlier it was 0. If you look back, when plane was passing through origin, right, you see, when plane was passing through origin, so right hand side was 0, but now, but left hand side is same. If you notice, left hand side is same. Yes, आपका जो लेफ्ट हैंड साइड है x plus 5g plus 10g, okay, that is same. 5 by plus 10g, that is same, right? But right hand side got changed. What is the reason? The reason is your plane is not passing through origin. The condition is same, that is, perpendicular to the normal, but now the plane is not passing through origin. If the plane is not passing through origin, okay, it is passing through a point, okay, so that is going to, the right hand side will not be 0, right? So right hand side is equal to something like minus 3 here. Okay? That is the indication. And I will tell you the shortcut as well, right? I mean, you can just, so what you can do here is, you see here, okay, so you have just kept here, and you got this equation, right? You just manipulated and you got this equation. So can you tell me what is the coefficient of this equation? You see 1, 5 and 10. What is 1, 5 and 10? The coefficient of this equation is going to be the normal vector component. They are nothing but the component of a normal vector, right? You can notice this. This observation I wanted to make you realize. If normal vector is there, you can directly write the equation of a plane. You don't have to do this much steps. Just wanted to make you feel. That's why I did. But whenever normal vector is given, you can directly write the equation of a plane. How? You see here, the coefficient of x by g in this equation or in the previous equation that we have got, the coefficient of an equation of a plane is going to be the normal vector component. Okay, the component of the normal vector, right? Okay, so 1, 5 and 10, they correspond exactly to the normal vector, right? That's something you have to remember. Okay, so these coefficients correspond to a normal vector 1, 5, 10. And what does this constant term roughly measures? What does this roughly measures? What does this talk about? ये क्या बताता है? How far you move, okay, from the, let's say that your vector was here, I mean your plane was here, and how far you're moving, okay, how far you're moving, right? That talks about that. Okay, please remember that. Okay, so the constant term here roughly measure how far you move, okay, from, let's say you have a plane, okay, that is passing through origin, okay, then the right hand side will be 0, that is for sure. But if you move parallel, if you move uh, parallel to the plane, right, okay, if you move to a parallel plane, then this number becomes something else. Okay, that 0 is going to be changing, right? 0 becomes -3 here in this case. So how could we have found -3 more quickly? Can someone tell me? How can we find this -3 more quickly? So we have got x plus 5y plus 10g equal to -3. So how can we find -3 more quickly? See, we can find, this, right? See, left hand side is very simple. Okay, to compute left hand side of the equation of a plane is very simple, because the coefficient of x by g, is nothing but the normal vectors. Okay, correspond to normal vector, right? But -3 कैसे find करें more quickly? I'm going to give you the trick. Okay, okay, remember this -3 talks about what? How far your plane is, right, from the origin, you can say. Okay, so how could we have found that -3 more quickly? So, well, we know that the first, okay, part of the equation is like this. Okay, कैसा था? If the point P naught is there, okay, that is passing through, you can say point P is there, P naught, okay, that plane is passing through that point. If you plug that point P naught, okay, if you plug that point P naught in the left hand side of the equation, ठीक है, ये जो left hand side equation है ना, इसमें अगर आप point P naught plug करते हो, so what you can do here is, let me write, to get this, plug P naught in the left hand side. So you can plug P naught. What is P naught, guys? P naught is nothing but, let me recall that. P naught was 2, 1, -1. 2, 1, -1. So if you plug here, this is 2, this is 5, and this is -1. So, 2 plus 5, that is 7, and this is -10. So you got 3, right? So if you plug P naught in the left hand side, okay, that will result -3. This is how quickly we can write the equation of a plane. Okay, if normal vector is given, okay, and if we have to find, if we have to find plane through origin, it is very simple. Directly write the equation. Okay, using the component of the null vector, okay, that is coefficient times x plus coefficient times y plus corresponding coefficients, okay. But if they are saying that plane through certain points, so you can write the left hand side of the vector using normal vector, okay, left hand side of the equation using normal vector, and then right hand side कैसे compute करते हैं? Consider that that point is passing through origin, right? So that will satisfy, okay, that is going to be satisfying. So this is kind of a particular value that we want to get, okay, particular solution kind of thing. Yeah, so I believe this is fine for all. Yeah, everybody understand that? So what we can say here is, let me write everything properly, so you know, ये आप short note में लिख लेना, keep in short note, quick calculation, right? So let's say that you have got x plus 5 pi plus 10g, which is minus 3. So this coefficient of these numbers 1, 5 and 10, they correspond to what? They correspond to normal vector. Normal vector component. Okay, in general, whatever equation you have seen, you can understand that ABC correspond to null vector component. And how do we evaluate the right hand side? That is a question. So value of this minus 3 is nothing but what? This is a value of, okay, this is nothing but a value of what? A left hand side of, value of left hand side at P naught, at that point P naught. If you take P naught and plug in the left hand side, you will get minus 3. So this is the idea that you have to remember always, so that you can find anything very quickly, right? I think this is clear for all. Yeah, so these are the basic things that you should know, okay, you should know, understand. So that is what I wanted to teach, okay, and so please remember these points, okay. So in general, you can remember, let me say that in equation of the form, okay, ax plus b by plus cg equal to d, right? So you have to remember that this, the coefficient, a, b, c, these are now component of the vector, okay. They are nothing but what? The null vector of n. If they are asking you, let's say you have been given a plane equation, okay, and they want to know that what is the normal vector, right? So you don't have to do anything, right? You can directly find the normal vector, right? So this is nothing but a normal vector. Normal vector कैसे find करते हैं? This is how we can find out normal vector, right? Okay. And in multivariable problem, right, always if we are realizing any surface, okay, so there will be always a vector, normal vector will be there, right? Some normal vector will be pointing outward, okay. So we have to know exactly what is that normal vector. If the surface is a plane, okay, kind of seat like structure, so the ABC, ABC directly you can say that, forget about the right hand side, okay, the component, the coefficient of x by g, you take it as a component of normal vector, okay, and you can write it, right? So this ABC is going to be the normal vector, okay, of, this is very important, right? So for example, you can say that, so we can find, how can we find normal vector to a plane if we know points in a plane? That is a question. See, if you know points in a plane, how can we find the normal vector, right? Okay, so we can take the product of two vectors contained in the plane, right? Let me take one example here, right? So let me take that, for example, so ये चीज आप याद रखना हमेशा. And how can we find this d? D can be found out you know, d is nothing but d you have to calculate. D is nothing but what? D is nothing but the value of ax b by plus cg at t naught. You can say x naught, y naught, g naught. ठीक है, ये आप याद रखना. This is important to remember, right? Fine. So let me take one question here. So for example, we have to get an like vector by cross product of two vectors, right? So we have seen that, right? Since we have got a two vectors, so we can get n in the plane, right? So we can take the cross product a cross b, that will give us, that we have seen non-vector, right? But let's say you have got a plane directly. So how can we find the directly? You can. So let me take one problem here. The problem is, what is that problem? The problem is nothing but the vector is given, right? So the vector, let's say this is a vector, okay? And vector I'm writing in terms of, you can say, component only, right? 1, 2, minus 1. You can write also in terms of column vector if you want, right? And they have given, and the plane. See, they have given some vector v, right? And they have given plane here, right? The plane is nothing but x plus y plus 3g equal to something. What is that something? That is 5 r, right? Okay, so we have to take some condition here. You can say that the vector v and the plane are parallel. Second is perpendicular. Okay, and third is neither. Are they parallel? Okay, the vector, see, this vector is there. This vector we don't know whether it is a normal vector or, right? They have given some vector, right? Okay, and they have given some plane here, and they are asking whether they are parallel or perpendicular. How can we ensure that any vector which is present in the plane? ये बहुत important है linear algebra के लिए. Visually तो आपको पता है कि yes, let's say this is a vector here, plane here, and this is a normal vector, right? You can say, so yeah, it will be perpendicular always. This is a vector, and if it is going to be like this, so we say that yeah, it is parallel to that, okay? But how can we ensure mathematically that a vector and the plane, whether they are perpendicular or you can say parallel? How can we say that? That is very important. I think many of us do not understand that. Okay? Yes. So most of you might be answering, this vector and the plane are perpendicular to each other, right? Because since we discuss, okay, but do you think it is correct? Yeah. But there are some other answers, okay? I mean, so you have to ensure that, right? So what is the equation here? I mean, the example is this, right? Okay. The vector is given and this is given, and now they are asking whether they are parallel or perpendicular, right? Or neither, right? So what is the solution? How to understand that? Okay, so from the experience you will understand in future, right? But here we can do something mathematically, right? So v is there 1, 2, minus 1, and the plane is x plus y plus 3z equal to 5. So v is there, that is 1, 2, minus 1, and your plane is there, that is x plus y plus 3g equal to 5. Okay, remember that this is not a point. Okay, the plane is plane is not passing through origin also, because there is a right hand side. Okay, if there is a right hand side, means plane is not passing through origin. Okay, and if I talk about normal vector component, so what is normal vector component? The the coefficient of this equation, right? I mean left hand side, 1, 1 and 3. Okay, but this is not a normal vector given. Okay, that is a vector. Okay, but we have to find whether this vector is you know perpendicular or parallel to this plane, right? So okay, so what is non-vector? Let's say that plane is there, this is a plane, right? And we can say that this is a normal vector, right? I think finding normal vector is very easy to this plane, right? What is this normal vector? So this normal vector you can find out, right? So normal to a plane, what is going to be a vector? So normal, this is the first step, right? You can say step number 1. Normal to a plane, the normal vector is gonna be what? In terms of just write component, that is 1, 1 and 3. As we know shortcut, right? Okay. We don't have to derive it, just directly we can write by inspection, okay? Okay. So I think this is clear, right? Okay. Take the coefficient of x by g, okay? That is going to be perpendicular to the plane. Okay, so how do we get all other vectors that are perpendicular to a plane? Question is, how do we get all other vectors that are perpendicular to a plane? कैसे फाइंड करते हैं? So all perpendicular vectors, remember that. See, if I say that, let's say that this given vector is perpendicular to this plane, right? Okay. Okay. It means this vector, given vector will be like this. Yeah, the dimension, I mean, the length of the vector can differ. Okay. Length of the vector can be different, right? Like this only, right? Some vector v, you can say, right? But it is still perpendicular, you can say, right? This vector is perpendicular. But how can we say that? If they are perpendicular to the plane, it means they will be parallel to the normal vector. Yeah. See, they are parallel to normal vector, right? They are in the same direction. उनका जो length है, the length of the vector can differ, can be different. Okay. Length, or you can say the norms of a vector can be different, right? Or norms. Okay. So all the perpendicular vectors are parallel to each other. That is very important consequence you have to do. All perpendicular vectors are parallel to each other. Okay, all perpendicular vectors perpendicular to the plane I'm talking about. All the perpendicular vectors to the plane, I must say, are parallel to each other. Are perpendicular. So how can we find other vectors? Parallel to each other means what? So we can get other vectors just by multiplying some scalar constant with normal vector, right? So we can just obtain by multiplying some scalar constant with the normal vector, because we know normal vector. Okay, क्योंकि आपका अगर वो parallel, let's say that this vector we know, right? This vector we know, and if something is parallel here, so what we can do here is we can scale this vector. We can get this vector now. Okay. So that is very important. So two vectors are parallel to each other, means one vector can be found out by multiplying some scalar constant to another vector, right? That is what very important thought process you need. But you see, notice that what you have to notice. You have to notice that this normal vector and this given vector is not proportional to each other. Parallel का मतलब होता है proportional होना चाहिए ना. But okay, given vector v and normal vectors are not proportional to each other. Okay, we can't find the given vector v by multiplying some scalar constant. Okay, so v is not a perpendicular to a plane, therefore देखो कितना अच्छा मतलब थॉट प्रोसेस है, पूरा ज्योमेट्रिकली दिख रहा है. therefore v is not perpendicular right, perpendicular to a plane. ठीक है, दैट इज वेरी. सो आपको जब भी कोई नया वेक्टर आएगा, इफ एनी वेक्टर इज देयर, एनी प्लेन इज देयर एंड दे आर आस्किंग वेदर दे आर perpendicular to each other, right? Okay, whether they are perpendicular to each other, so you have to first see whether they are whether that vector is proportional to the normal vector or not. If that vector is proportional to the normal vector, then only that can be perpendicular to that plane. Okay, how can you get the normal vector? You can get the normal vector very easily, right? Okay, I think this is very beautiful problem, right? So being perpendicular to a plane is same as what? Being perpendicular to a plane is same as being parallel to its normal vector. That is very important statement. Being perpendicular to a plane is same as being parallel to a normal vector. Normal vector, you know. And what is the meaning of parallel to a normal vector? They should be proportional to each other. Okay. Vector is proportional to normal vector. Parallel का मतलब यही होता है in terms of, you know, okay, in linear algebra we need to understand these things. Okay, so being perpendicular to a plane का मतलब क्या होता है? Being parallel to a normal vector. Okay, and what is the meaning of parallel? So that is very important to, I encourage everyone to study like this. Okay, so if you want to test, okay, parallel to a plane, right? So what about this vector v is parallel to a plane? If they are asking, they are not perpendicular, but if I want to test whether this v is parallel to a plane, what is that testing? How to test? The next question is how to test v is parallel to a plane. If it is parallel to a plane, मतलब क्या होता है? Let's say that this is a plane and the vector v is given, it is parallel to a plane. It means it is normal, na? So it should be perpendicular to a normal, right? I mean, their dot product must be 0. It's a very amazing concept, right? Right. So how to test if someone is gonna ask you if any vector is given and the plane equation of plane is given? So first of all, from the equation of a plane, you should be able to find you know, the normal vector, right? And if somebody asks you that whether this vector is parallel to a plane, so what you have to do? You have to just take the dot product with the normal vector, right? So parallel to a plane means you can say that it is perpendicular to the normal, right? And if it is not perpendicular to the normal, then it is not going to be parallel, right? Okay, so v and n, they are not perpendicular, right? Means they are not parallel. Since they are not parallel, okay, that is very, very important to keep in mind. Yeah, so v is not parallel to n. V is not parallel to n. The meaning is that it corresponds to what? Not perpendicular to a plane. That is clear. That is the first idea. Okay. And the second idea is what? V perpendicular to, then you have to think about V perpendicular to a normal vector n. Okay. So V dot n must be equal to 0. That is the very important point. Okay. If it is equal to 0, let me take that. This will ensure that whether your vector is parallel to a plane or not. Okay. Vector is parallel to given plane. Very beautiful idea, right? I always get fascinated. What is V here, guys? V is given as 1, 2, minus 1. 1, 2, minus 1. 1, 2, minus 1, okay, and 1, 1, 3. Your normal is 1, 1, 3, right? Okay. So if you're going to take the dot product, so it is 1 plus 2 minus 3, which is 0. Yes. So you can say that given vector is parallel to the given plane. It's a very important result, right? Okay. So what is your answer? Yes. Your answer is gonna be yes. So whenever you want to geometrically plot it, so your answer is yes. V is parallel to plane. V is gonna be parallel to plane, right? I hope this makes sense to all, right? So if you have got a plane equation of plane, there are two different things that I have told you, right? A point, let's say you have got a point is not in the plane, matlab kya hai? Very simple to, you have to take care of these points, right? So I just want to conclude now, right? Okay. Let's say that this vector is given, that is 1, 2, minus 3. Okay. This vector, sorry, what is given? 1 minute. What I want to explain now is, see, we have got a plane equation, right? And we have got some vector, right? So if many of us, what we always do is we try to take that component and put in the equation, and we try to see that whether it is satisfying or not, right? Okay. So if you take a vector, okay, if you plug this vector, okay, to the plane equation, okay, so right hand side becomes 0, right? If you take it here, let's say that this B is nothing but what? 1, 2, minus 1. So 1, 2, minus 1, right? So it becomes 0, right? It becomes 0. Okay. We are getting 0, right? What is the meaning of that? Remember that it is not a solution to the plane equation. That is very important to remember. It is not a solution to a plane equation. Okay. It is not a solution to a plane equation. Okay. Solution to a plane equation is nothing but what? A plane is going to pass through some point, right? That is going to be the solution. But if you plug vector into the plane equation, that is not going to be a solution. Please remember, solution is a different thing. Okay. Solution is going to be a different thing. Okay. That is nothing but the value of x and y z that satisfies the equation. Okay. Let's say that, see, there are two different things. There are two different things. Okay. Always remember there will be two different things. Let's say that a coordinate is there. Let me take a coordinate. You can say 1, 2, -1, right? It's not in the plane, you can say, right? 1, 2, -1 is not in the plane. Not in the plane. This point is not in the plane. Okay. So what that tells us is, if I put my vector v at the origin, if you put that vector v at the origin, okay, let me put that vector v at the origin. Let me draw the geometrical picture here. X, y, and g, right? So if I put this vector v at the origin like this, okay, understand? So its head is not going to be in the plane. You see here, this head, and my plane is here, right? It is not passing through origin, right? That is given. Because this point 1, 2, -1 is not in the plane. Please remember that. Okay. Coordinate, if you look at 1, 2, -1. What is this 1, 2, -1? That is the vector, right? And this is not in the plane, right? It means that if your vector is starting from the origin, and so this head is not in the plane, you can notice, okay, not going to be in the plane, right? So on the other hand, okay, the left hand side evaluates to 0, okay. It might happen if you plug this vector, and the left hand side is going to be evaluating 0, but that is not the solution, okay. That's what I want to convey here, okay. So the equation of this plane is going to be what? You can say x plus y plus 3g equal to 5. But where this vector is, this vector v is originating here, right? So you can say that the plane is here, okay, that is going to be x plus y plus 3z equal to 0, okay, and this plane is parallel to that, okay, parallel plane through origin. So I think this is clear, right? So these things I wanted to teach, and these are very important points. So आपको जितना मैंने बताया है, please remember that, okay? Regarding your plane equations and all, right? So this will be very useful. These concepts are useful in linear algebra as well. Okay, और machine learning में ये सब यूज होता है, right? So please remember that. We'll meet in the next session. Okay, thank you.